Hey guys, as you know by now, if you've been following our channel or if you're Dr. Kishimoto, we're Christina and Sasha. Today we're going to be talking about lightning. Lightning strikes the earth 100 strikes per second on average, and it's the second weather-related cause of death. Side note, in case you were wondering, floods are actually the leading cause of weather-related deaths. So we know that lightning is really important, but it's also very important to know exactly why they happen in order to stay safe in the environment. Lightning is caused by movement of air that goes up and down. That causes the movement of charge. Negative charge, or the buildup of electrons, occurs at the bottom of the cloud, which you can denote in pink here, while the positive charges hang out at the top of the cloud, somewhere up here, because clouds can actually be miles long, so we don't necessarily have to draw that in right now. The cloud is now polarized because of this movement of charge. The ground, the earth down here, has positive and negative charges on it because that's how atoms work. But the negative charges of the cloud have the effect on the ground. Because we know electrons move more easily than protons, negative electrons on the ground get repelled by the negative buildup on the cloud up here. We know that like repels like. So the negative atoms per electron are just all the way at the bottom of the object, while the positive charges come to the surface. This is also polarization. Therefore, we know that the charging of the ground is caused by induction through here. So as we were saying, everything else on the ground also gets positively charged by the same induction process. The trees that we see outside, the houses, and even people will polarize underneath this polarized cloud. All of the positive charges move up towards the surface in relation to where the clouds are instead. A lot of the positive charges do stay at the very tippy top and the sharp objects. So things that are closest to the clouds or the highest objects in the landscape will have a buildup of the positive charges. This is why in a wilderness survival scenario, you're supposed to avoid flat fields during the lightning storm.
Because even little humans like Christina can be struck.
This is because you will be the highest part of the landscape, no matter how much higher it is in relation to the rest of your landscape. So these negative charges will be easily attracted to the closest positive charge, and in that case, that will be you going down here. Lightning will travel through the object with positive charge. So let's say we're finally going to have a fun little lightning strike here. The tallest thing in our landscape right here is this tree. Trees are greatly struck by lightning all the time. It's pretty ridiculous, the rate of lightning strikes. So we'll have a fun lightning, and here's the tallest thing. That's what it's getting attracted to. We get hit. Even if the lightning were to come from over here, it's still attracted to the highest point in the landscape 9 times out of 10, really. Lightning will seek the easiest route to the ground, which is why it's going up through here. Even though bark isn't necessarily a great conductor of lightning, it's much better than just the air particles because we still have this entire polarized tree. Even if you're standing underneath a tree and you're not the tallest thing in the field, if you're standing next to the tallest tree, it's still a pretty bad idea because lightning is continuing to go all the way down here, get into the roots, and dissipate all through the ground. If you're standing close enough, it will get you, and you get hit by lightning.
So, as we said before, lightning always seeks the easiest route to the ground. This is really important because this is a very dangerous phenomena, and scientists would love to study it to learn more about it and also learn how we can avoid it. So, the best experiment yet is that scientists will study lightning by creating lightning with a rocket. So we have this rocket that has a long coiled wire attached, and what will happen is they will shoot it up into the cloud that is forming lightning. Because we have this wire that is normally a great conductor, such as copper, will provide a straight path back to the ground, and because it's such a good conductor, it will actually take the negative charges that we have in the cloud and create a lightning bolt coming straight down to the positive charges that we have in the ground. Because of this, there's no erratic path for the lightning to follow, such as when we have the tree over here. So it's easier to study because scientists will know exactly when and where the lightning will strike at this point on the ground. Another way One way by studying this we have learned to avoid lightning is by Ben Franklin and his great invention of the lightning rod. A lightning rod is just a conducting metal pole that is set atop the highest point of a building. It sticks straight up, no bends anywhere in the rod, and it's usually there is a coil attached to it that runs the length of the building that you have. In this scenario, it's our house, and will go a few feet down into the ground. So if there's ever a lightning storm around your neighborhood and for whatever reason lightning wants to strike your house, it will strike the highest point, which in this case will be the rod. Because you have the coil attached, the lightning will travel from the rod into the coil, down the length of the coil and into the ground. This will ground the lightning, and it will dissipate into the ground and leave your house unharmed. So the last thing we're going to touch on today is the thing that usually accompanies lightning, which is thunder, the big boom. And so lightning is a huge electrical discharge and creates a lot of heat. So usually what happens is you have your lightning bolt, and the air around this bolt gets very hot very quickly, which causes it to also expand rapidly. This expansion will create a big sound wave that cracks and creates what we call thunder. A lightning bolt is also made up of several segments, which is why when we draw it, we draw out all these twists and turns. Each segment will create a different sound. So me, as a little human right here, I am closer to the bottom of this lightning bolt. So I will hear the crack from that bottom segment before I will hear the crack from the top segment. This is also why we hear so many cracks of thunder for each lightning bolt that we see, because each segment, the thunder created by each segment will reach your ears at different times.
So hopefully now, because of physics, you actually know how to survive if you're ever caught in the middle of a thunderstorm and why this is happening the way it happens. Other than that, if you have any questions, please feel to like, comment, or subscribe to our channel. And Merry Christmas!